Okay, so we talked about displacement time graphs. We talked about the shape of displacement and velocity and acceleration time graphs, but we haven't really talked a whole lot about velocity time graphs and sort of done any calculations. So that's the next 2 days' job. Then we're going to get into the word problems, and then of course we're going to have an opportunity for you to show me what you know. Does it say test? This is a 5-day week, right? I can't see us being ready for Friday. I don't see that possible. So I'm going to say, I'm going to aim for like Tuesday. Yeah? We'll aim for Tuesday and we'll go from there. To be determined. Okay, so now this is after the next 2 days. I haven't split this up completely. So today we're going to calculate average acceleration, displacement. Oh, we're not going to do that today. That'll be the next day. That'll be the next day. We'll do that, and probably that one. Morning, Colin. Okay, let's begin. So velocity time graphs, you will remember that velocity time graphs show the velocity of the object as it moves, right? So average acceleration is calculated the same way that average velocity is calculated on a position time graph. That is by using the slope. Right? Average acceleration is the slope of the VT graph, and we talked about that on Friday when we were drawing graphs and all that sort of stuff, right? Acceleration is the slope of the VT graph. Now, I'm going to just say right up front, I'm going to warn you, the most common error made is people don't recognize what kind of graph they're looking at. So it's very, very, very important you check over there on the y-axis to see exactly what kind of graph you're dealing with, right? Because we've got displacement time graphs, now we have velocity time graphs. Okay, so how do we find the slope? Rise over run. So if I'm asked to find, oh, by the way, you're going to do, I'm going to show you interval A, and then you're going to do a bunch of other ones right away. So slope of interval A is this one right here, this yellow highlighted area here, so from 0 to 2 seconds. So it's rise over run, so it goes up 4 minus 0, all over the run, 2 minus 0, right? The x-axis, so that's 4 over 2, or 2 meters per second squared, and we talked about why the units are squared. The average acceleration during this interval right here is 2 meters per second squared, because the slope is 2 meters per second squared. Okay? All good? So I would like you to find the average acceleration for interval A, B, you get to do A even though, guess what? I gave you the answer already, right? So A and then B is there. B is from 2 to 5 seconds, C and so on, right? Okay, I got to start this, don't I? Okay, let's begin. I'm pleased to see that everyone got question number 1 right. I'm not overly surprised, but I'm certainly pleased. I will point out that in the past, people have actually got it wrong, even though I've given you the answer. Okay, you guys ready to listen over there? Here's the learning part. Here's the part where you figure out what you did wrong. Okay, so A, yes, the slope is 2. B should be automatic. It's 0. B is 0. Interval C is from 5 to 7. The correct answer is minus 2. Let's just do that. What's the second Y? 0. The first Y is 4, so it's 0 minus 4. The second X is 7. The first X is 5. 7 minus 5. 0 minus 4 is minus 4. 7 minus 5 is 2. Minus 2 meters per second squared. Minus 2. Not sure what happened there. D is this little interval here. Also minus 2. It's the same slope, even though it's below. It's still the same slope, isn't it? Right? If you wanted to actually do it, what's the y value here? Minus 3. What's the y value here? 0. What's the x value here? Looks like 8.5. And the x value here is 7. So it's minus 3 over 1.5, which is minus 2 meters per second squared. You're finding slope, minus 2. What's the slope for E? Yes. Everyone got it right? That's good. The slope for 6 is plus 1. Let's have a look at how we do that. What's the second y value? 0. What's the first y value? Minus 3. 0 minus minus 3 is plus 3. 11 to 14, you don't even have to look at the graph. I give you the x values. It's going to be 14 minus 11, which is 3. And 3 over 3 is 1 meter per second squared. Had lots of different answers, apparently. You have to be able to do slope. You have to be able to do slope. You will struggle on the test without the ability to do slope. If you still don't know how to do slope, get a hold of me. Learn it. Don't put it off. No retests. Learn slope. It's not hard. Okay. When is this object stopped? And the correct answer is never. Why is it G never?
You didn't tell us that you did that. Yes, we did. It says it on there. I don't read the booklet, you know that.
Well, Taryn, if you learn anything today, maybe it's to be read the instructions. Its acceleration is 0 meters per second squared. It is not stopped here. Not stopped. What does this? It means you're going at a constant speed. Exactly. Now, aren't you glad that this is a meaningless little check, meaningless little... Okay? I don't even look at those. Okay? It's just a way for you to learn. So it is not stopped there. It means it's at a constant velocity. That's right. So when is the object moving backward? Correct answer is D, E, and F. D, E, and F. How come? Because the velocity is negative. It's a velocity time graph. No, none of C. No, this is C right here. The velocity is positive. It's not the slope we're talking about. When is the object slowing down? Now this one's even harder. Watch carefully. Slowing down means that it's, I'm going to say, approaching 0. Where does it approach 0? There and there. C and F. Approaching 0 means slowing down. When is it speeding up? When it's moving away from 0. Where does it move away from 0? There and there. Right there, it moves away, the value moves away from 0, right? We're not talking about the slope now, we're talking the value. So the correct answer is A and D, not F. F has a positive slope, but that doesn't mean that it's
moving towards you. Yeah.
When is it moving at a constant speed? There and there. Flat. B and E. And is that the last question? Okay. I'm going to leave displacement for tomorrow. Okay? It's a bit of a challenge. I do want to, I'll go through this tomorrow. We'll do that tomorrow as well. I want to talk about 4 and 5 though. Okay? 4 and 5. Instantaneous velocity. Can you find this page here where it says 4 and 5? Yeah, you know what? Okay, so did everyone find these? Are you guys paying attention? Because I'm going to start this. I don't want anyone saying now, where am I looking? Because you haven't been listening. I'm asking you to find this page right now. You should have it. You have the graph.
We do not have the graph.
It's on page 3. Yeah, it's the same graph we've been using on the front page. Okay, it's the same graph. So it's page 3, where it says instantaneous velocity. How do you find instantaneous velocity on a velocity time graph? You simply read it off the graph. How come? It's a graph of velocity. It's a graph of velocity. So to find instantaneous velocity, guys, listen. Here's the learning part. You got to listen. To find instantaneous velocity, you actually have to read it off the graph. What's the instantaneous velocity at t is equal to 6 seconds? 2. Okay, it's pretty easy. I'm just going to do this one manually. What's v inst at 13 seconds? Right here. -1 is your answer. All right, v inst, read it off the graph. What about instantaneous acceleration? Instantaneous acceleration, we are now talking about the slope. Ladies, are we listening? The slope of a VT graph. So instantaneous acceleration is determined the same way off a VT graph that v inst was determined off the position time graphs. That is, find the slope of the VT graph. You may need to draw a tangent line when it is curved. If it's not a straight line, what do? So say, for example, a inst at 6 seconds. Right there, we are looking for instantaneous slope. It's a straight line, so we just find the regular slope because it's a straight line. So it's going to be 0 minus 4 all over 7 minus 5, which is minus 4. 7 minus 5 is 2, so it's minus 2. That is the instantaneous slope. If it's a curved line, you have to draw a tangent. Okay, so there's a bunch of exercises at the back there. There's, I'll go through this summary thing here tomorrow as well. There's 4 graphs, I think, am I right? 4 graphs? Okay, so in all 4 of the graphs, the first few questions are just acceleration. So in other words, graph A, you can do A to F. In graph number 2, you can do A to E. In graph number 3, you can do all of number 1. You can do number 4. And in the 4th one here, it's a mishmash, isn't it? Okay, just do those 3. So again, graph number 1, A to F, just the acceleration ones. Graph number 2, A to E. Graph number 3, numbers 1 to 4. You have answers, you have a solution QR code, and you have a link as well. Yeah, do you have answers in the back? Okay. So tomorrow I'll do that displacement stuff, and then I'll basically give you time to work on the rest of those, and we'll see where we're at on Wednesday.